Hi, this is Practical Uses of an AI Assistant. My name is Dave Stokes. I am the Community Manager for DBeaver. And if you want to copy the slides, they'll be up in speakerdeck.com/Stoker in a little while. So I introduced myself earlier. I've been using open source databases since they become available. As a matter of fact, if you want some interesting reading, I've written one book and 2 editions of how to use JSON with MySQL. And today I'm going to talk to you about using AI with a database. Now, I am the first person to admit that artificial intelligence is overhyped. It's being sold as the cure-all for everything and the demon for everything else. It actually is really good when working with a database. There are some places where it actually shines. And I'm talking, it can make your life a lot easier. A lot of things you don't have to chase. You'll see some examples of that later on in this demo. AI is great for pattern matching. And unfortunately, if you're working with a database, you are doing a lot of pattern matching, so it's a natural fit. So one of the areas it helps is syntax. If you're fat fingering something, it can do it. If you're trying to figure out how to write a CTE, it can do it. If you are looking at a couple tables and trying to figure out how to join them together, AI can do that. It's great for data description language. Give me a table for this type of data, and away it goes. It is superlative for that. Writing queries, you'll see in a little while that it is very good for writing queries, especially when your boss gives you something in management speak, and you're trying to figure out how to translate it into something that Edgar Cod would be proud of. So where we're going to concentrate today is where it can help you in analysis, in writing, and building, and planning. It is a very useful thing to have an AI assistant peeking over your shoulder. It saves you a lot of grief and speeds up your processes. So what can you honestly expect to do with AI in your database? Once again, AI is overhyped. There are some limits, and you'll see some of those very quickly. We'll look where AI works well. There are some areas right now where it is pretty snappy and does some great stuff. Other areas you'll see where it needs some help. And it can write some pretty good code, but pretend like you're a senior in a programming shop and you have a junior person who's coming up who's just learning SQL, and they're pretty good at some of the syntactical stuff, but some of the planning stuff kind of slips by the cracks. You'll find out that you are the one responsible. So treat it like a very junior DBA just learning the trade, and you'll do fine. So just how good is AI at the simple stuff? Well, about 2 years ago now, I was reading about AI working with databases, and my first AI was not that impressive, as you'll see. Where I first started out was I asked 4 LLMs the same question. The prompt was asking it to do something. I gave it an assignment and mentioned the database and not supplying a lot of details about it. Kind of like you got when you were starting out and your boss would ask you to do something. Sometimes it's a road of discovery and you tend to stumble into the potholes. So what I did is I said, using the MySQL World Database, how do I find all the cities in the Texas district and their populations? Why this database? Well, it's been around for 3 decades. It's been used in MySQL documentation, training, examples, and documentation, and every place else for 3 decades, so it's fairly well known. The one thing I will point out is that Texas district, most Americans say state of Texas, but the way the database is set up, and you have to have some prior knowledge here that the Texas is a district according to this database, so this gives it a little bit of a leg up there. So I asked 4 different LLMs this prompt, and the first one I tried was Grok, and the output you get, as you see here, is fairly detailed. To find all the cities in the Texas district, and it has the query. Select name population from city where district equals Texas, and explains why it is doing that. So then it goes on to say, hey, if you want, we can order by population descending, which it can be handy. But remember, I asked it just to give me a list of the named populations. So if this was a junior developer coming to this and some of the first SQL code they wrote, you'd be pretty pleased with this. Now the next one, Google, was a little different. Um, as you see here, it says, and it's highlighted, you need first to identify the country code for the United States and then filter the city table based on that country code and the Texas district. Now, you and I probably know that there is not another Texas district or state out in the rest of the world. At least I hope not. As a proud resident of the Lone Star State, I'd be kind of shocked to find that. So they added this little interesting bit here to the where clause, where the country code equals select code from country, which is yet another table. So it's doing the subquery here, where name equals US and district equals Texas. A little different approach, but I'd give it at least a B-. Solid work there. Ollama, which is popular because it's open source and you can run it locally on your machine. You don't have to send your data all over the internet, hither, tither, and yon. With Ollama, I come through and I gave it the same prompt, and it came back with this query, which is very much like the first query. It's not doing like Google did and asked for the country. Very, very good. Same class as the first example. ChatGPT, nice presentation, explains why it's doing stuff, and pretty good. Now, as I mentioned, all of them had this part of the core of the query pretty standardized. Select name, population, city, where. Now, Grok, ChatGPT, and Ollama both had district equals Texas. Google went the extra mile to make sure that they were all from the United States and not from some other Texas. But overall, I thought this was good. I was very happy with that. Now, the conclusion I had, well-known database, so LLMs were trained on it. It's been out there for 30 years, so it's knowledge about this database is out there, and there was been using it for a long time. But I didn't give it a lot of information. Now, the responses were pretty consistent, other than Google, and all produced good SQL that did the job. But what about a case where the data is not so well known? Well, I wanted to go out and, let me go to conclusion. 1A conclusion. I tried the same experiment with Postgres with the same data, and the results were horrible. But you'll see some of the results a little bit later. Why is this? Well, the world database is not known well in the Postgres world. So asking Postgres world about the world database is like asking the Formula One world about sprint car racing. There's some similarities, but there's not a lot of depth there. And you'll see some of that later. So example 2, wanted to use Postgres. So I wrote the prompt, write the SQL to create a table on Postgres 18 server. Notice I'm specifying a particular version to store customer data. I'm not specifying anything other than that on the extensions or anything like that on Postgres. The data will include a first name, a last name, an address, a birth date, a unique UUID primary key. That's kind of an oddly specific thing, but the type of things that a data architect will hand down to a DBA. Then I asked partition data by year of birth and produce test data of at least 10 records. This is what something you might get from someone who wants this data schema really quick, and they may not, or they may have good reasons for the recommendations of things like UUIDs. So when I was doing this, I had some personal goals. I wanted to let the AI do the majority of the heavy work. I wanted to write no SQL, not no SQL, no space SQL. I wanted to do the absolute minimum that I could. It's kind of like I hand this off to my minion who goes off and does the work and comes back, and hopefully they can come back with something good. And I used the DBeaver AI explain fix to correct issues. I'll talk about that in just a minute. Well, I'll talk about it now. The AI explain fix opens an AI chat with detailed explanation of the error and a corrected query, which can be immediately executed. Now, for those of you worrying about setup, I am using DBeaver Enterprise Edition, and I'm using OpenAI with GPT-4. When you start this up, you go out, get your token, post it in there, select your model, and apply and close. And if you need a demo, let me know. I'm always happy to do that. Reach out to me online. So here's an example of using it. I'm selecting customer ID, name, last name from customer GPT. This was a customer table. I'm asking, you'll see how I got this generated later when I asked the four same LLMs the same information. Notice this is last name and this is name. What I've done is fat fingered. There's no first underscore name. So when I go to run the query, I get this error, column name in field list unknown. So when I hit the AI explain and fix button, it comes back and I say, please explain, or it feeds it into the AI and says, please explain what's wrong with this. It shows the SQL, shows the query. It comes back, says the error message indicates there's no column name. And it's pretty smart. And it figures you should use first name instead of name. And here's the corrected query. And I can execute it, copy it over to the editor, or cut it for pasting later. So once I do that, have first name instead of just name, query runs beautifully. So how do these four LLMs again do now that I've asked it to create this database? And once again, I thought this would go a little bit better, but you'll see what happened. And it was actually a good thing. So with Grok, the first thing it wants to do is enable PG crypto. So it could actually create the random UUID, does the extension, creates a table, ID, first name, last name, address, birth date, primary key. Notice the primary key is made up of the ID and the birth date and the partition. If you had a junior who came up with this on their first try, you'd be happy with it. The partitioning of the data. They're doing it in 5-year increments, which is interesting. And you'll see why some of the other ones do. ChatGPT also wants PG crypto. ID is UUID, primary key default. First name, last name, address, birth date, partition by range, birth date. The only trouble is when you go to run that, this is why I was using the AI explain and fix. Primary key constraint on table lacks column birth date, which is part of the partition key. So we need to go back and have that fixed and change our primary key to ID and birth date. And here's their data. They're doing it by every decade starting in 1980. Google Gemini, once again, PG crypto, similar that it has the UUID for the customer ID, text, date. We can go into why text is more valuable later. Primary key, customer ID, and birth date, partition by range birthday. The partition is also by decades, which I thought was interesting. The test data is fairly generic. Olama with the Gemma 3.5. It does also everything like you expect. A little different is it has birth date, which is a date field, not null. Birth year is an integer, not null. A created at and updated at timestamp with a default time zone of now, which I thought was an interesting bit there. And it creates the partitions. It's like every decade again. And when I go to build this, the create table lacks birth year, which is part of the partition key. So run that again and fixes. And there's the test data. But when you go to run input the test data, it complains about the row contains birth year equals 95. It lacks column birth year, which is part of the partition key. So ask what the error actually is. And here you see to fix this error, you need to create a partition in the Olama customer table that can accommodate the birth year value of 1995. So a quick overview. I asked for IDs of being in UUIDs, works. Names varchar 100. If you live in a country with fairly short names, that might work. Past couple of years in the Postgres world, text is kind of taken over from varchar, so I'd be team here. Birth date is all saved as date. Primary key, ID birth date, ID birth date, ID birth year, and birth year and customer ID. Now, the partitioning I thought was kind of interesting. Grok wanted 80 to 81, 85 to 86, 90 to 91. Kind of got carried away there. Google was doing it by decade. Olama doing it by decade, and ChatGPT by decade. So creating a new table by LLM is a mixed bag. Sometimes it knows what it's doing. Other times it's going to do something wrong. It's going to create errors. By the way, all 4 LLMs, if you do this with SQLite or MySQL, give you much better results than Postgres. You'll see one glaring reason for that later with ChatGPT. Partitioning schemas, you probably want to specify what you want. How are you going to deal with folks who are born before 1980? Is every 5 years or every 10 years too big of a leap? Also, character fields, as I mentioned, you might want to go from something from varchar or text instead of varchar. So, DBeaver's AI assistant. Well, security. Every time you fire it up, it's going to ask you for the master password to get into the program. So if you have it, leave it open on your laptop, someone can run it. By default, it only sends over metadata, the DDL, the schema. You can have it move over foreign keys and keep that out of there. You can also say, okay, you don't get any of the data, you just get the schema. But if you want it to work better, it helps if you give it some sample records to go. You can exclude tables, filter them out. So if you're looking at customer information and you don't want the junior to be able to see credit card information, you can filter that away from them. Once again, I'm using DBeaver Enterprise. Here I'm using OpenAI. And in the configuration, you can see the various choices. Over on the configuration, I can actually say what I'm sending over. Like default, it's send column data type information, the metadata, send over description, send over foreign key, send over unique and primary keys. You can also tell it, hey, explain this like I'm 5 years old when you give me the reason why something's going on, or please give me less detail on the explanations because you're just too verbose. Like I said, first time you fire it up, it's going to ask you, is it okay to go out and get the metadata? And you have to type yes or it doesn't get it. And simply in the SQL editor, you preface a English language or German or Basque or French or Polish at AI, who are the top 5 customers and how much revenue did they generate? And you'll see something like this. There's our prompt. Over there is the SQL generated by the AI assistant. And down here is the result. If you have a very complex schema and relationship between the tables, the AI can figure that out for you. You can also do something that's interesting is in a comment, select 5, just a dash the comment start, 5 top cities for revenue, type in the word select, and then Control Alt plus right arrow, and it'll go out and generate the SQL for you. So if you have it quick and dirty and you don't want to try to figure out how the city changed the address table, which changed the customer table, and how you get there from payment, let the AI handle that. Makes writing simple queries very, very quick. And if you want to pretty print it, we have a pretty printer that neatens that up. Something that used to happen to me all the time when I was a production DBA is you get the database thrown over the fence. Hey, someone in this other department came up with this database and All three people there love it, and some senior VP wants to make this the new thing for the company. We're not sure if it's going to scale. We're not even sure if the software is secure, but we're going to give it to you, and you get to see if we can turn this in production. So what you do is type describe database object. And in this case, I've gone out to the DBeaver sample database, which is an SQLite database that comes with DBeaver, so you can do test queries. And for this sample database, it tells you the database schema consists of several interconnected tables that store information about a music store and talks about the various tables. So if you got a schema you don't understand, this is great, and it'll tell you how they relate to each other. Maybe it's just one table that has you worried. And in this case, under that sample database, we're going to look at the artist table, and we're going to describe the object again. And it tells us that the artist table in the database schema is the key entity. It stores information about various artists. It's obvious from the name of it and the type of information here, but if you have something that's like TK_1-dev, this is the type of information you would love to be able to get fed. Now, what if you have questions about a query? You've inherited something that you run once a quarter that everybody seems to rely on, but you have no idea how it works. What you can do is you can say, what does this query do? And then paste in the query, and it will come back and tell you this query is designed to retrieve information about the top 5 customers who have rented films from the most distinct categories and have the highest total spending. And it breaks down what the steps are. Augment queries on the fly list. This is something that also troubles a lot of DBAs, is that they come in and they'll say, hey, this is great, but I need this broken down by region, or could this be a quarterly report instead of a yearly report? Could you add this other information from the customer table, like whether they used a coupon or something like that? So we have our original query over here. And we say, okay, take this information and list by state and list the revenue. And we asked the AI to take that query and do that. As you can see here, it's a little more complex of a query. It does a few more joins, and it orders by revenue. And the great thing is I did not have to sit down and figure out how these tables join in. I just asked the AI to do that. So it makes it very, very quick. Now, where an AI goes wrong, this was a big shock for me. I was thinking back to when I was a kid. There was a TV show or a TV program that had old movies, and one of the movies they showed was something called Colossus: The Foreman Project, which, if you ever see it on a streaming service, it's worth a watch. The basic premise is that an American scientist has created a artificially intelligent supercomputer, which back in the 60s was unheard of. And it was called Colossus: The Foreman Project. Of course, they bring this up online. And during the Cold War, this is going to help us protect us from the evils of the world, only to find out that yet another country has one of these, and these two supercomputers link up and decide they're going to run the world. Great AI, great movie, a little bit of AI fear in there, but it's worth a watch. So AIs do have potential to go wrong, as Hollywood has warned us. And here's an example using ChatGPT. So I just typed in a simple prompt for a talk I was doing. How do I use JSON table with Postgres 18? Well, JSON table was added to Postgres before Postgres 18, but ChatGPT does not know that. As a Postgres 18, there's no native JSON table function like you might know from Oracle Database or MySQL. The trouble is, it thinks it knows what it's doing, but it's going to take you down this rabbit hole of using some other JSON/JSONB functions. And when you ask it, what is the latest version of Postgres that you've been trained on? And it's current as a Postgres 16, which is now getting kind of long in the tooth. If you're using an LLM that's been trained on bad data, your results are not going to be trustworthy. Now that we have the MCPs that can actually go out there and do more probing, they might be a little more afield, but they still might pull back the wrong data and announce that this is absolutely beautiful data that you can trust, but you can't. Unfortunately, you have to double check all this. Unfortunately, I have a bunch of great examples. Unfortunately, I can't do them because this is pre-recorded. Maybe if you have questions about that, contact me, david.stokes@dbeaver.com, and we'll set up something where we can actually run through some examples. So if you're asking me, do you need an AI assistant? And I would say, well, go out, download the free open source community edition of DBeaver, or use a free 2-week trial of DBeaver Enterprise or any of the other versions that we have, and give it a try. And to my mind is you need an AI assistant, much like if you're still coding in Emacs, you're missing out a lot of stuff from GUI interfacing editors that do code completion. You really, really need to look into having an AI assistant. You get to write quick and dirty queries or complex queries, or as much as you want, or as little as you want. Language support is there. It can explain queries or data structures for you. If you have something you just are not happy with or not sure of, it can walk you through it. As you saw, it can quickly augment existing queries to add new features. It lets you do as much or as little coding as you desire, which is something I like. And also with MCP, hitting all the tools, your AI is going to be able to go out and get a lot more information for you, and you will absolutely love what it can do for you. Now, once again, this is pre-recorded, so we can't do questions and answers, so please contact me if you have any. And with that, I want to thank you. Hit me on LinkedIn. The slide deck will be on speakerdeck.com/Stoker. I'm david.stokes@dbeaver.com. You can find me on the DBeaver Reddit page. And with that, I want to thank you for tuning into this, and I hope you have a great day.